in a previous video, we started to get an intuition for rate curves and what the area under a rate curve represents. So for example, this rate curve, this might represent the speed of a car and how the speed of a car is changing with respect to time. And so this shows us that our rate is actually changing. This isn't distance as a function of time. This is rate as a function of time. So this looks like the car is accelerating. At time 1, it is going 10 meters per second. And at time 5, let's assume that all of these are in seconds. So at 5 seconds, it is going 20 meters per second. So it is accelerating. Now, the relationship between the rate function and the area is that if we're able to figure out this area, then that is the change in distance of the car. So rate, or speed in this case, is distance per unit time. If we're able to figure out the area under that curve, it will actually give us our change in distance from time 1 to time 5. It won't tell us our total distance because we won't know what happened before time 1 if we're not concerned with that area. And the intuition for that, it's a little bit easier if you were dealing with rectangles. But just think about this. Let's make a rectangle that looks like a pretty good approximation for the area, let's say from time 1 to time 2 right over here. Well, what does this area of this rectangle represent? To figure out the area, we would multiply 1 second, that would be the width here, times roughly, it looks like about 10 meters per second. And so the units here would be 10 meters per second times 1 second, or 10 meters. And we know from early physics, or even before, that if you multiply a rate times time, or a speed times a time, you're going to get a distance. And so the unit here is in distance. And as you can see, this area is going to represent, it's going to be an approximation for the distance traveled. And so if you wanted to get an exact version, or an exact number for the distance traveled, you would get the exact area under the curve. And we have a notation for that. If you want the exact area under the curve right over here, we use definite integral notation. This area right over here, we could denote as a definite integral from 1 to 5 of r of t dt. And once again, what does this represent? In this case, when our rate is speed, this whole expression represents our change in distance from t is equal to 1 to t is equal to 5. Now, with that context, let's actually try to do an example problem, the type that you might see on Khan Academy. So this right over here tells us Eden walked at a rate of r of t kilometers per hour, where t is the time in hours. Okay, so now t is in hours. What does the integral from the definite integral from 2 to 3 of r of t dt equals 6 mean? So before I even look at these choices, this is saying, so this is going from t equals 2 hours to t equals 3 hours, and it's essentially the area under the rate curve. And here the rate is, we're talking about a speed. Eden is walking at a certain number of kilometers per hour. So what this means is that from time 2 hours to time 3 hours, Eden walked an extra 6 kilometers. So let's see which of these choices match that. Eden walked 6 kilometers each hour. It does tell us that from time 2 to 3, Eden walked 6 kilometers, but we don't know what happened from time 0 to time 1, or from time 1 to time 2. So I would rule this out. Eden walked 6 kilometers in 3 hours. So this is a common misconception. People will look at the top bound and say, okay, this area represented by the definite integral, this tells us how far in total we have walked up until that point. That is not what this represents. This represents the change in distance from time 2 to time 3. So I'll rule that out. Eden walked 6 kilometers during the 3rd hour. Yes, that's what we've been talking about. From time equal 2 hours to time equal 3 hours, Eden walks 6 kilometers. And you could view that as the 3rd hour, going from time 2 to time 3. Eden's rate increased by 6 kilometers per hour between hours 2 and 3. So let's be very clear. This right over here, this isn't a rate. This is the area under the rate curve. That's what this definite integral is representing. And so this isn't telling us about our rate changing. This is telling us how does the thing that the rate is measuring the change of, how does that change from time 2 to time 3? So we would rule that out as well.